Welcome to the Binomial Expansion Extended next level. So previously we obtained or showed roughly where this formula comes from that I'm highlighting here. This is in the formula book at A level. And we talked about the fact that this is true for any real number now. So we can do binomial expansions for rational numbers and irrational numbers. Typically we'll be doing rational numbers and they could be positive or negative. We said that it's only true for a certain range of values and it actually falls apart for outside of that range, and it's technically an infinite series, but we truncate it and it's useful for making approximations because typically, because x is small, we're going to try and make x really small and these later terms won't matter. But be aware, to be exact, actually it is an infinite series. So what we're going to do today is we are going to extend it slightly because at the moment we've only looked at 1 plus x. What if I have a number here? How am I going to deal with that? And we're going to look at some other sort of scenarios as well, that some of which you will have encountered for the normal binomial expansion, but it's good revision of that as well. First thing I want you to do is have a go at these two questions. Can you write the binomial expansions down up to the terms that it says? Pause the video, try it out. Right, I'm going to talk through the first one. So for the first one, I've got this little x in my formula is actually going to be 5x because in my expansion that's what I have. And then n is going to equal minus a half. So I can write down that 1 plus 5x to the minus a half is going to equal, and all I'm going to do now is apply this formula. It's going to be 1 minus a half x plus minus a half times minus 3 over 2 divided by 2. Okay, technically it's sort of 2 factorial or 2, it doesn't matter, it's just 2 in this case. And then it's going to be 5x squared. And I've already realized I made my first mistake. It's very easy to do this. Okay, so which is why, to be honest, I wrote it out here. Okay, so it's very easy to forget to put the 5 in, but I shouldn't have done that because I've written it out. I've now corrected it. I'm okay. Remember I said you can just substitute right in for the formula and write minus a half minus 1, or you can start by actually just calculating what that is. You've got one more term to work out, and it's going to be the same sort of thing. It's going to be minus a half times minus 3 over 2, and then I just minus 1 again, so it's minus 5 over 2. And this time I'm dividing by 3 factorial, and then it's 5x cubed. So let's work out what this gives us. The first two terms are quite easy to write down. It's going to be 1 minus 5 over 2x. Okay, this next term, right, I'm going to get 25x squared, and then I'm going to times it by 3, that will give me 75, and then I'm going to divide by 2 3 times, so it's going to be 75 divided by 8. I've got a double negative, so actually I'm going to get plus 75 over 8x squared. Last term, in a similar sort of way, I've got now a triple negative, so I'm going to cancel out those two. I'm going to get a negative for my term. This is going to become 125x cubed. Okay, the 3, let's write as 3 times 2. That 3 is going to cancel with that 3, so I'm left with 125 times 5, which is actually 625, and then I'm dividing by 2 4 times, so I'm going to be dividing by 16 in total. I'm going to be minusing because there's a minus here, and I've got an x cubed here. I've done it without a calculator, but to be safe, you would then at least check that with a calculator in an exam scenario. I'm pretty sure I'm okay. For what values is the expansion valid? Valid for modulus of x less than 1. So in this case, that's going to be minus 1 less than 5x less than 1, which is 1/5, sorry, 1/5 less, minus 1/5 less than x less than a fifth. Okay, so that is my final answer for there, and this is my final answer for the expansion. Okay, hopefully you got that, and maybe you skip through the video to check that. That's absolutely fine if you want to do that, and do the same here. So here I've got the n is equal to -4, and now x in inverted commas is actually kx. Just going to grab my formula. Okay, I've got it to refer to. We've done the hard bit. We've seen where it comes from. It's fine now. Although this just seems a bit like you're just substituting in values. You are, but you're showing your understanding of applying the formula, and there'll be other questions that test your understanding further. Okay, so we're going to get that it is 1 plus kx to the -4. These take a while, don't they? Okay, keep going. 1 minus 4, but then I need my kx. Don't forget to put the k in there. And then plus -4 times -5, lowering 1, divided by 2, kx squared. Okay, actually, I've only had to go up to x squared in this question, so it's not quite so bad. So 1 minus 4 kx, and then that's going to give me 20, double negative, divide by 2 plus 10. That's going to become k squared, x squared, and we are done. And now we could deal with questions that might say, oh, the coefficient of the x squared term is 200. What is k? Or a similar, they could give you some information about that. So yeah, we can expand these sorts of things where we've got an unknown in there as well. We're going to do two more questions now that use the binomial expansion, this extended version, in a slightly different way to what we've looked at previously. So I would suggest again, you just try this out and see how you get on. I've got one thing to note before you do that though. The questions I put in the starter are going to help you with this. I put them in the starter to get you to practice what we've done last lesson, but actually it turns out that they'll be useful. So think about that as you do these questions. You won't necessarily have to do your expansion from scratch. I'm going to go through them. So find the x squared term of this thing here and state the values of x for which the expansion is valid. Okay, well this thing here looks horrendous at the moment, and we don't want to expand just the denominator. Okay, we don't want to write it as 1 plus 5x to the power of a half and expand that, because then we're just going to get 2 plus x divided by some infinite series, and that is not going to really help us if we want this x squared term. The thing we have to do actually is write it down as 2 plus x multiplied by something, and it's going to be 1 plus 5x. It's a negative because it's a reciprocal, and then because it's a square root, it's minus a half. So we need to have this really quick understanding of powers at this point in A level. All right, and how am I going to get my x squared term? Well, before I worry about that, let's expand it. So the 2 plus x is going to stay the same for now, and I'm going to focus on this thing here. But I've already dealt with it, haven't I? And I'm only, okay, let's write it all down. Here it is. So can I just copy it, grab it, and move it down? Yes, I can. Okay, this was our answer. So you can go straight for it as well. And I know I've missed a bit off the screen, but we'll see why that doesn't matter, because I can actually cut it off here. I don't need this x cubed term. Why is that? Because look at it. I want the x squared term from this thing. The only way that's going to happen when I multiply this out is if I do 2 times 75 over 8x squared. That will give me a term in x squared. Or x times minus 5 over 2x. If I times by cube terms or times other terms, I'm not going to get my x squared terms. So make sure you understand that. Think, where's the x term going to come from? Where's the constant term going to come from? And so on. And we're only interested in the x squared term here. So the x squared term is going to be 2 times 75 over 8 x squared, and then here it's going to be minus 5 over 2x squared. That's the only place, and I can now work that out. I'm just going to get my calculator out over here. Okay, and I get 65 over 4x squared. Well done if you got that as well. So yeah, if we hadn't done the starter, you would have had to have done this expansion from the start, obviously. Okay, and for state the values of x for which the expansion is valid. Well, we've only expanded one thing. Okay, the 2 plus x is not an expansion, that's just a function. So the expansion is going to be valid for the same range as we had before. It's this thing here. So I'll just bring this down. It's not meant to happen. Okay, valid for these values. I'm not going to write that in. Right, next one. Hello, we've seen this before, haven't we? And this is basically what I was talking about. I said sometimes you might be told the coefficient and you have to work backwards. Okay, so pause the video and have a go at this. All right, well, we've done the hard work already in the starter, so let's just grab it. If I can, come on. Yeah, oh, I missed a bit of the 4, that's all right. So in this expansion, the coefficient of x is 20 and the blah 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 x squared. Now, so that's basically saying we don't care. There are other terms in this expansion, x cubed, but we're not interested in these. There's no reference to them in the question. So how are we going to do this? Right, well, it says the coefficient of x is 20. So it's basically saying that this thing here is equal to 20. So I can write down that minus 4k equals 20. And that's going to mean that k is minus 5. Lovely. And then I want to work out the corresponding coefficient of the x squared term, x squared coefficient. That is going to equal 10 times, and I can just substitute in minus 5 now, 10 times minus 5 squared, that's going to be 25, 250. Okay, so again, if we hadn't done the expansion already, we would have had to have done it at that point in the question. But once we've done that, this is very similar to the sort of thing you get in first year binomial expansion. I'd say this question here is a little bit different. You don't tend to do this sort of thing, but you would have done things like it. So it's just a little recap on that, but applying it to our next level binomial, our extended binomial expansion. We arrive at the main bit of the lesson today. How are we going to expand things when it's not 1 plus x, it's not 1 plus 7x, which we can still deal with, but it's 4 plus x, or 4 plus 20x in this case. How on earth are we going to deal with this? Are we going to need to create a whole new formula, or can we somehow use this one? I want you to really have a little think about this. You might already know, but if not, don't just wait for me to tell you. Think, how can I take this and apply this? All right, spoilers coming, okay? Okay. Well, we want to make it so there is a 1. So the first thing we can do is we can take out the factor that to get us a 1. So I can take out a 4, and inside it will become 1 plus 5x. So I basically made 4 plus 20x, 4 bracket 1 plus 5x. Now I still need to raise all of this to the power of minus a half. And so note, I have put the whole thing in a square bracket this time, just to distinguish which brackets go with which. But this is the crucial bit. Crucial. I didn't know whether to do like a smiley face or what there actually, but just make a note that is crucial, because now we can deal with it. Because now this becomes 4 to the minus a half, 1 plus 5x to the minus a half. Okay, I've raised both that power, and 4 to the minus a half is 1 over the square root of 4, so it is a half 1 plus 5x to the minus a half. And I've managed to turn this into a problem that I can now deal with, okay, because I know how to expand this. And this is how we're going to deal with it in A-level. Because we're given this formula, we're going to practice it, learn how to apply it, and then in the cases where we don't have a 1, we need to just modify it slightly. Now note, we've already dealt with it, haven't we? Actually, I've done it again. It's the same thing that I had before. This 1 plus 5x all to the minus a half. So I don't have to do the whole thing from scratch. There's no point in wasting lots of time doing expansions. I want you to be practicing them yourselves. Okay, so actually my next line is going to be the same as before, but I need to put a bracket around it and then put a half in there. I've just realised we did it up to x cubed before, but I got rid of that x cubed term, didn't I? Okay, let's grab it again. So it was, where's it gone? I've lost it. It went off the page, I remember, and I can't get it back. I crossed it out. Here it is. Got it back. Okay, so that should also be in the bracket because we're looking for up to x cubed. Okay, so get rid of that one. Yeah, so if you're encountering this question for the first time, this would be a first step, this would be a second step, third step, and then you would expand this, okay? And you'll have some working, which will eventually simplify to this. And then just finally, I would get rid of the bracket. It would be a half minus 5 over 4x plus 75 over 16x squared minus 625 over 32 x cubed. And it's going to be valid. When we look at where it's valid, we're going to look at this thing here, not the original one, okay? Because if we look where it's valid, we have to have a 1 in there. And it's going to be the same thing as before. Okay, so the fact that we've got this extra factor of a half is not going to affect the range of values at all. It's just going to affect the function that you actually get. So it's valid for minus a fifth less than x less than a fifth. Okay, nice. Feels good, doesn't it? Right, one more. And I've definitely not left enough space here. Sorry about this. Not very professional. Okay. Find the binomial expansion of 4 minus 3x squared to the power of a half up to and including the term in x to the 4. Okay, this is just another example where we don't have a 1 in there, and I've also got an x squared inside the bracket, not just an x. But hey, we can deal with this. Let's grab the formula at the top. Come on, come on, come on, yeah. Okay, first thing, what is it? We need to get it so it's in the form 1 plus x to the n. So, what we're going to do, we're going to write down the function 4 minus 3x squared to the half. And in this case, I'm going to again take out a factor of 4. So it's going to be 4, 1 minus, and in this case, I'm going to get a fraction, 3 over 4. It's not always going to, it's not like when you learn to factorize at GCSE and you have to take out something that goes into both. We're moving factorization on, and we've got a fraction here, but it's okay because it serves our purpose. Again, I've used square brackets, and next step is going to be to write 4 to the half, which I'm going to straight away write as 2, and no messing around here. 1 minus 3 over 4. Oh dear. 1 minus 3 over 4 x squared to the half. Okay, so I've transformed it into something that I can deal with. What? Up to x to the 4? That is a lot of terms. Okay, let's see what happens. So 2, and then I'm going to... right, let's just backtrack. I've got that n is equal to a half, and I've got that my x, in inverted commas, is minus 3 over 4 x squared. So I need to put all of this in whenever I see an x into my formula at the top. So it's going to be 1, and then I've got plus a half, and then my x is actually minus 3 over 4 x squared. There's that first term. Second term, plus a half times minus a half, because I'm minusing 1 from my n, divided by 2, x squared, but it's not just x squared, it's minus 3 over 4 x squared, and then I am squaring that as well. Oh, just about fit that on. I technically need to close this with my green bracket because I can stop there. I'm interested in going over to up to x to the 4, but because my powers, like these x's are actually x squared, I'm going to get x to the 4 here, and I don't need any more terms, so it's not as bad as I first made out. Okay, I'm going to leave the 2 there and sort this stuff out first. So it's going to become 1 minus 3 over 8 when I multiply those out, x squared. And then what's going to happen here? Okay, I think this is worthy of an extra step. So I think what I'll do is a half times minus a half is minus a quarter, divided by 2 is minus an eighth. So it's going to become minus 1 over 8. I've just dealt with this part of it. And then I'm going to square minus 3 over 4x squared. So that is going to become 9 over 16 x to the 4. Hopefully you see where I got that from. And we're basically there. I think I can just expand the whole thing now. So this is going to become 2 minus 3 over 4 x squared. And I'm going to need to do an eighth times 9 over 16 times 2. I can do this actually without a calculator quite quickly, because 2 times 1 over 8 is 1 over 4. And I just need to do 16 times 4, which is 64. So it's going to be 9 over 64. And I've still got that negative in there. So 9 over 64 x to the 4. And that is us doing a binomial expansion on something pretty complicated. It's now got a number there, not 1, and it's got a function of x that's not just a constant times x, it's 3x squared, but we can deal with it in exactly the same kind of way. Whew, wait a minute. For what values of x is this expansion valid? We've not dealt with that yet. Okay. Right, I'm actually going to do something a bit different now, because we've sort of been rushing into writing the expansion down, what it's valid for. But because I've got an x squared there, I think I need to treat it a little bit more carefully. So if it was the modulus of x is less than 1, I need to change it to minus the modulus of minus 3x squared is less than 1. Valid for modulus of minus 3x squared less than 1. Okay. Notice the negative doesn't really matter. Although I realize all of x squared is always going to be positive. But x could be negative. So anyway, let's think about what's going to happen here. When I take the modulus, the modulus means you take the absolute value, so you always take the positive. But because 3x squared is always positive anyway, if I take the negative, like this is going to become 3x squared less than 1. Basically, it makes sure it's positive. But 3x squared is positive, so I know that this is how it is. I feel like I didn't explain that very well. But this is what we get, okay, when we get rid of the modulus sign. Now, what's going to happen with that? Well, I can write down that x squared is less than a third. And if you remember how to do this, well, you could solve it as a quadratic inequality. I think I'm not going to do that in this case. I can draw x squared, and I can look at where it's less than a third, and it's going to be in these ranges here. It's going to be in this interval here, and that is going to be when we take the square root, and it's going to be minus 1 over root 3 less than x less than 1 over root 3. Okay, that is my final answer. I think that's quite tricky, and I'm sorry if I didn't explain that as well as I could have, but I'm just going to go through it one more time. Okay, we've written this down because this is exactly what we had in the formula. But what I'm saying is, although we'll do more on the absolute value, if I'm explaining it now, the absolute value makes it positive. Okay, so to make it positive, we're going to need to get rid of that negative, and it will become 3x squared is less than 1. I can divide through by 3 and I get x squared less than a third. Now I can plot the graph and I can think about the range of values for which that will be true. The way I've tended to teach it, to be fair, is I've said, right, write it as x squared minus a third is less than 0. And then actually, you know what, plot that function, like complete the square. Okay, this would become x plus 1 over root 3, x minus 1 over root 3 is less than 0. So that tells you your roots of the equation. It's going to go under the graph. Where is it less than 0? It's less than 0 in this interval. So the answers, the roots are going to be 1 over root 3 and minus 1 over root 3, and the answer is going to be that it lies between those values. So sorry, I think I did a better job that time of explaining where this comes from. In any case, this is the answer. Right, let's just quickly look at the function itself, because I've not done this lesson. So in red is the actual function, okay, and it only exists between this range, because once you go beyond that range, you're going to be taking the square roots of a negative. If we look at how good it is, if we take our terms up to x to the 4 in blue, it is very good in this interval between minus 1 and 1, I'd say. I mean, it's getting, you can see a difference between when you get to 1. And then it becomes not so good near to the boundary. That's what we expect, because you need to take more terms to get accuracy. If I take more terms, and I've actually not made a note, I think I've just taken another 2 terms, then as before, it does become better. But there's always going to be some error, you know, right at the boundary, because you've got an infinite series and it's not going to go to 0 very quickly. So you need to take more and more terms. Whew, okay. Right, so just to summarize, we've looked at some other problems for binomial expansion extended. We can now deal with ones where we don't just have a 1 there, we just take it out. Just remember to take it out. Okay, I just see people forgetting to take it out. It's just shocking every time. So every time you look at a binomial expansion question, think, right, I want to get a 1 plus x. What do I do to get that? And then sort it out. Be aware of, you know, this is quite hard, I think, this like the range of values, but hopefully that made sense. But make sure, I would personally write down the range of values every time I do this sort of question. But yeah, we can have functions of x in here as well. And that is, yeah, we could have like sine x in there, and we could expand it in terms of sine x. That could be quite fun. But for now, over and out, that is binomial expansion extended, next level.